All right, in this chapter of parallel and perpendicular lines, now we're here in section 2. Section 2 deals with parallel lines and transversals. So transversal comes from our section 1 notes. The transversal is a line that's basically crossing other lines going in a general direction. So in this diagram here, this would be the transversal. And the fact that we're dealing with parallel lines means that we're going to be starting in this section with being given lines that are parallel. And so you're going to see these little red arrows. So in your diagrams, when you see red arrows, that means that the lines are parallel to one another. And just reminding us of the definition in section 1, parallel means that they will never cross in the same plane. So these lines will be in the same plane. They'll never cross. Going a little bit deeper, that also means that they have the same slope, even though that we don't necessarily need that piece of information in this case. But for right now, we will start with information being that we have two parallel lines, two or more. We'll see the arrows showing that they never cross, and then they'll be cut by a transversal. So this is kind of our starting point in this section. Okay, and so we're going to revisit some of these other key terms from the previous section as well. Corresponding angles means same position. So the example I give here is angle 1 is corresponding to angle 5. So top left, angle 1 and angle 5 are corresponding. Now, there are other corresponding angles as well. 3 is corresponding to 7, 4 corresponds to 8, 2 corresponds to 6. But the main property that we need to understand here is that corresponding angles, same position angles, will be congruent. And that term congruent means that whatever the measurement is, so for instance, angle 1, if angle 1 happens to measure, say, 80 degrees, then whatever corresponds to angle 1 has to also be 80 degrees because I have two parallel lines. Okay, if these lines were not parallel, this would not be the case. So this is special only if I'm dealing with parallel lines. All right, so corresponding angles will be congruent. Alternate interior angles or diagonal inside angles, say for instance angle 3 and angle 6, they will also be congruent to each other. So angle 3 and angle 6 are diagonal inside angles, and because the lines are parallel, these two will be congruent or the same measurement as each other. 4 and 5 are also alternate interior, meaning that they will also be congruent to each other. Whatever angle 4 is, whatever angle 4 measures, angle 5 will also have to measure the same. All right, next up, alternate exterior. Alternate exterior means diagonal outside. Diagonal outside. So for instance, 2 and 7 are alternate exterior angles. And much like the first two, they will also be congruent to each other. So whatever angle 2 measures, angle 7 has to be the same. These tend to be the ones that students are able to latch onto very easily because they're all congruencies. Okay, you just have to make sure that you associate the correct angles with each other. So going back to section 1, understand that corresponding means same position, alternate interior means diagonal inside, and alternate exterior meaning diagonal outside. As long as you can get the positions down, those three positions will be congruent to themselves respectively. Okay, the tricky one, the one to circle here, the one to star, the one to focus on, because it's easy enough to remember that these will just match each other. And just to clarify, they will not all match each other. Corresponding angles will match one another. Alternate interior angles will match one another. Alternate exteriors will match one another. The one to understand here is consecutive interior. Now, consecutive interior means same side inside. So, for instance, angle 4 and angle 6 are same side inside angles. The reason I want you guys to circle this one, the reason I want you to circle it, star it, whatever you need to do to draw attention to it, is because this one has a different property. They're going to be supplementary. So if you need to write this in your margin over here, supplementary means that it adds to make 180 degrees. So for instance, angle 4 and angle 6 are consecutive interior angles, same side inside angles. 3 and 5 are also consecutive interior angles, so the same property applies to those two. But different than these first three, where I have things that are matching or equal or congruent, supplementary angles need to add together to make 180. This one tends to be a sneaky one for students, so just make sure that you have this one circled. It's just different than the first three. Again, as long as you can understand the positions, you'll be fine. So just burning through this example right here. If in this diagram, angle 1, you were told the measures 80 degrees, we can actually use that information to find all the rest of the angles. And here's how. So in your margin, make sure you write down these two definitions. First off, vertical angles. Vertical angles. Vertical angles, this deals with something in the previous chapter. For instance, 2 and 3 are what we call vertical angles. We have a single intersection here. Angles directly across from each other will have to be congruent. 1 will be congruent to 4, 2 will be congruent to 3. So for instance, if angle 1 we're told is 80 degrees, that's going to force angle 4 to also be 80 degrees because they're vertical angles. So in your margin, make sure you understand that vertical angles are congruent. And you can write in that 1 and 4 are vertical angles, so they have to be the same. 2 and 3 are also vertical angles, we just don't know what they measure yet. And here's where I want you to write down a second definition in your margin. Linear pair. Linear pair goes back a couple chapters as well, but linear pair literally means two angles pair, two angles that make a line. For instance, angle 1 and angle 2 make a straight line. They're what we call a linear pair. And the difference here is that a linear pair, much like this property, will be supplementary. A line is 180 degrees. So any two things that make a line have to add up to make 180 degrees. So if that's 80, I would have to just subtract that from 180 to find my remainder. In this case, 100 degrees. So because of linear pair, because this is 80, that's going to force this to be 100. Okay. So vertical angles are congruent, linear pairs are supplementary. Those deal with the single cluster, any intersection. Those two properties can be applied. All right. So now dealing with these properties. These properties now compare two different clusters. And so we can use the information within one cluster to translate the information down here. So because of corresponding same position angles, 1 and 5 have to be the same. So if 1 is 80, 5 has to be 80. If 2 was 100, because of linear pair up here, if 2 was 100, angle 6 has to also be 100. Okay. And then you could also use vertical angles and linear pairs within that cluster once you have something in there. But using some of these, because of corresponding angles, 1 and 5 both have to be 80. Because of alternate exterior angles, 1 and 8 have to be 80. Now if we used vertical angles up here to find out that angle 4 was 80 degrees because its vertical angle was angle 1. If angle 4 is 80, now because of alternate interior, 4 and 5 have to match, diagonal inside, so angle 5 has to be 80 as well. And just to use our last one here, consecutive interior, if I know that angle 4 measures 80 degrees, again because of vertical angles, if angle 4 is 80 degrees, that means that the consecutive interior or same side inside angle has to add to make 180. And so if that's 80, I can subtract it from 180 to find that that's 100. And we can use that information again to find any of those angles. All right, so let's go into the examples. So in the notes that are also linked in the Google Classroom, we have the following. And I'll leave this on the screen for a little bit so that you can copy down the examples. I'm going to work through them on a whiteboard though. So if you need to, pause and you can start copying these down. But for now I'm going to move over to the whiteboard. All right, so part A. Our job here is to find the value of x. So these are the types of examples that you will see throughout your chapter, your section. Okay, so here's a typical situation. We're given two parallel lines, and forgive me for using the big markers because they're a little bit dull, but okay. So these two red arrows mean that these two lines are parallel to each other. It means they'll never cross in this plane. This is what we would call a transversal. And so I have two parallel lines cut by a transversal. So all those four properties will apply. Corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. All four of those properties and their attached rules have to apply to the situation. So then it just becomes a game of what rule can I apply to the situation. Now in this case, I have this angle and this angle. As it's drawn, there is no property of those four properties that relates these two pieces. So there's nothing directly I can do to relate these two values. But what I can do is I can use one of my other properties, vertical angles. And vertical angles will tell me that this value right here has to also match whatever this one is. So this is 115. This angle right here must also be 115. So if that's 115, that must also be 115 degrees. So now I have two pieces right here that I can relate. Consecutive interior angles, same side inside angles. And the rule there is that these have to be supplements. They have to add to make 180 degrees. So below this, I'll go ahead and set myself up with an equation. My job here is to find x. So ultimately I need to get x by itself. So the trick here is to come up with an equation that can get x by itself. And the equation here I can use deals with consecutive interior angles. These two together have to add to make 180. So my equation can be 115. Again, that came from the fact that these were vertical and had to match, plus this x plus 5. So those two together, added together, have to equal 180 degrees. That is because of consecutive interior angles. Consecutive interior angles. So if you need to write that to the side of this equation to understand where it came from, take the time to do that. So at this point now, this is a chapter 1 problem. Basically, collect like terms, move things away from x so I get x by itself. So I can combine the 115 and the 5. They're on the same side of the equation, so I just do the operation just as it's written. So 115 plus 5 is 120. Nothing happened to my x yet, and it still equals 180. Now to get x by itself, all I have to do is move the 120, and we would move that by subtraction since it's at positive 120. And then we would actually be able to get x by itself. 180 minus 120, 60. X has to equal 60 in order for this to work. End of part A. All right, part B. Part B, we're given a similar situation here. We're given two parallel lines, given by these red arrows, cut by a transversal. There's our transversal. And again, we're given this thing to solve where we need to solve for x. So I need to set myself up with some equation that I can then solve for x. And then the game becomes, again, can I find some pairing of angles or some equation where I can relate this so I can solve for x? So in this case, there is a property that relates these two positions. This is one where we will use corresponding angles. Bottom left, bottom left. And our property says that corresponding angles have to be congruent or the same. They have to match. So I can set each of these equal to one another because they have to match. So based on corresponding angles, this is the equation I can write. 3x minus 11 has to equal 7x plus 9. And because those have to match, this is now a chapter 1 problem. Now I can collect my like terms, move things away from the variable. So let's go ahead and do that. If I want to move this 3x over here, I would do it by subtraction since it's a positive 3x. And I'd have negative 11 equals 7x minus 3x is 4x. Continuing on, now I can have x in one place. Now I can start moving stuff away from it. I could subtract the 9. Negative 11 minus 9, be careful with your negatives. That becomes negative 20. Running out of room here. Just move to the side. Finally, dividing by the 4, we get x equals negative 5. Done.